Dear students, good morning. How are you? I am your physics teacher, Shafiq Malik, from Pakistan International School, Doha, Qatar. As you know, this is our 8th week of virtual learning. In our previous week, we started chapter number 7, Electricity and Energy. Today we will discuss more topics of this chapter. Therefore, all of you please open your science book, page number 90.
Learning objectives. At the end of this lesson, students will be able to understand the concepts of voltage and resistance. Recognize that any working electrical circuit needs a power supply to provide a voltage. Write the answers of test yourself questions on their notebook. Dear students, today our topic is power supplies and voltage. In our previous chapter, we have studied that a current is the flow of negatively charged electrons. In order for these electrons to flow, we need a source of energy. These sources of energy are power supplies. For example, dry cells and batteries, which are shown on this slide. Such types of dry cells are used in different devices, such as toy car, remote control. You also observe this battery in a car. These dry cells and the batteries are the sources of energy and provide a force to the current to flow in electrical circuits. This driving force in the dry cells or batteries is required by the current to flow and is called voltage. So we define voltage as the driving force of a current is called voltage and its unit is the volt. The symbol of volt is V.
Dear students, maybe you have observed, on a dry cell, 1.5 volts is written which shows its voltage. Similarly on this small battery, 9 volts is written, which shows its voltage. Can you tell me what is the voltage of that battery which is fixed in your father's car? And you know that many dry cells join together to make a battery with a bigger voltage. Measuring voltage. The other name of voltage is potential difference and its abbreviation is P.D. Voltmeter. Voltmeter is a device which is used to measure the voltage or potential difference. You can see the picture of voltmeter and its symbol on this slide. To measure a current, we use another device which is called ammeter. Ammeter is a device which is used to measure the current. You can see the picture of ammeter and its symbol on this slide. To measure the voltage, voltmeter must be connected across a component, that is, voltmeter must be in parallel to the component. For example, in this figure which is also given on your book, page number 90, the component is an electric bulb, so to measure the voltage, that is how much voltage is passing through this electric bulb, we connect voltmeter, parallel to the electric bulb. In this figure, the other components are key, which means switch, and battery. Dear students, like ammeters, voltmeters must be connected the right way round. If not, the pointer moves the wrong way and the meter may be damaged. Our next topic is resistance. Dear students, moving electrons face opposition while flowing through electrical wires. This opposition is called resistance. So we define resistance as, resistance is an electrical quantity that measures the hindrance to the flow of charge. It depends on several things. Number 1, thickness of wire, that is, a thin wire has more resistance than a thick wire. Number 2, nature of metal, that is, nichrome wire has more resistance than copper wire. Dear students, nichrome is an alloy of nickel and chromium, while copper is a metal, as given on slide. Heating effect – whenever a current flows through a resistance wire, there is a heating effect, because when moving electrons collide with the atoms of wire, heat is produced. This heating effect is used in many electrical appliances such as electric fires, irons and toasters, and also in the filaments of light bulbs. Dear students, the filament of a bulb is made from tungsten, which has a high resistance. Measuring resistance. In this slide, we will discuss how we measure the resistance. The resistance of a component or a circuit tells us how many volts are needed to make a current of 1 ampere flow through it. If a circuit has a large resistance, a high voltage has to be applied to get a current of 1 ampere to flow. If the circuit has a low resistance, only a small voltage is needed. Resistance is measured in units called ohms. It can be calculated using this equation: resistance is equal to voltage over current. Here, R is the symbol of resistance, V is the symbol of voltage and I is the symbol of current. Now we define ohms, which is the unit of resistance. Ohm resistance is equal to 1 ohm, when 1 volt voltage is needed to make a current of 1 ampere to flow. The symbol of ohm is omega, which is a Greek letter. Ohm is the name of a scientist. Dear students, this table shows few quantities, their units and symbols. Number 1, resistance is a quantity, its symbol is R, while its unit is ohm, and its symbol is omega. Number 2, voltage is a quantity, its symbol is V, while its unit is volt, and its symbol is V. Number 3, electric current is a quantity, its symbol is I, while its unit is ampere, and its symbol is A. Ampere is also the name of a scientist. Homework. Dear students, please note down your homework. Write down the answers of all parts of Test Yourself questions on your notebook. Learn, did you know, given on page number 90, 91 and 92. Solve the given worksheet. Write down the answers of short and long questions on your notebook. I hope you have understood the topics taught today. Thank you and goodbye.